There we go.
Alright, we're streaming.
Another way to do a free file library that has to get a free file library. So I think I like easy to set up. So
It is, yeah. There's something you don't want to say.
No, it's fine.
I mean, we're just doing this guy for this time around, so it's not.
So I shouldn't unplug that.
Well, when you, so yeah, this is what we'll plug into. You want it to test now?
Right, yeah.
And honestly, I can put my slides on this and use my notes.
Why don't we, I mean, we can test. We're not,
Let me just download.
We're not showing this.
I've got my PDF file online. I can just download it.
While I go to the library first, we need to let you read it, right? So I can write the number and just kind
well, why don't we just switch you over? Let's see if it works. If it works, then
I can actually use two streams.
Okay. Sure. Yeah. So this is Ben Purdy's computer. So that's fine, but.
Can I download a keynote file to your computer? Yeah. Awesome. Gosh, I'm hungry. This video.
You could also try just hooking up to your machine and see that. You want to just airdrop it to me and we can try that?
Or actually, let's try my machine because now that I'm thinking about it.
Yeah, I mean, this is where
Maybe copy the notes over.
Well, and two, I was going to run the server. Now that I'm looking at it, let's see if I need that too. So let me just go ahead.
Okay.
Yeah.
Are you ready for the HM?
Yeah, totally.
This table is so thick.
Yeah.
I just unwrapped it.
It's a
like-
feature.
It's nice, but it's a little
Better than the
much.
alternative.
Yeah.
Cool.
Yeah. Yeah, up that resolution a little.
I worry that this is a radical. 1080p?
I did best for that display.
Oh, best for the display. Perfect. Yeah, here we go. Thank you.
So they're doing a digital transform on
How do I go to your, what's your IP? Let me just go to that.
Prettybot.local should also get. Oh no, we need to be on the Wi-Fi. Hang on.
Yes.
What is the password? Helios Interactive. Oh, it's right there. Helios. Yeah.
And then it'll ask.
Yeah. And you and Helios. Success. That's quite the success message. Okay. So. 192.168.3.132. Oh yeah. Oh no. WebGL is not working.
I have
Well, so we're gonna run everything off your machine.
well, just for now.
Okay.
And then we can, I just wanted like this to be on here. Is that okay?
Yeah, that's fine. Yeah, I mean, if we have that on your machine, we don't even need mine plugged in, and then we won't have to swap cables around. What am I missing here?
No, don't worry about it. Actually, let me run my server on this just like I'm looking at yours. So let's put yours back in because we're going to need yours plugged in. Oh, I see. Yeah. So you're going to run the keynote on here,
but you're going to hit your server.
Yes. And I need to look at notes on it.
Okay, so we still need to get a keynote on the machine.
Yes. But that's on GitHub. That's fine.
Okay.
Yeah. So I can look at this one too.
I always try to do that too. It's good. I'm excited to see this talk, by the way. All your other presentations have been amazing.
This one is the. This one should be the best. I worked hard on it.
But yeah, for some reason, my download folder is a very crazy place. But I don't think I've ever run Keynote on this machine either. So.
Oh, awesome.
Grand experiments.
Oh, shit.
Much.
No, it's fine.
Okay, I saw particle though.
Is that alright for you, Phil? I just want to get some light over here so we can see your face and stuff.
Yeah, for sure.
So, in here under the presenter, I actually have you written as Bill Automata. Is that
That's great. Yeah, that's fantastic.
No,
It's not a big deal.
All good?
Yeah.
Oh, and the recording? Alright.
Yeah. Yeah, the sound will be just okay for tonight, but we'll get the video.
Every time you try something new.
Yeah. So we could do the headset mics again. I know people don't love
It's
those.
a smaller space though.
Yeah,
In
well,
theory,
the thing is that the headset mic would give us a really nice audio recording.
right, but we're not using any mics, right?
I've got a speaker mic
Oh,
here.
speaker mic,
So
okay, cool.
we'll get it. We'll get the audio.
Okay, but we're not doing like EA mics.
No, we're just doing yeah, your room is small enough. We don't need it in here. We're live. We're streaming from the living room.
Alright.
Then people get seated and we can start.
What time is it? We still have 10 minutes.
Well, I don't know. Actually, hang on. Bill!
How long are your Yeah, wait till 7.
The schedule gives him 45 minutes, which is.
Yeah, we've got way more than enough time. It's fine.
More time for hanging out.
That's
and
right.
poking
That's
us
right.
out.
No one's complaining.
Yeah.
And I need one of those illuminated keyboards.
Oh yeah, that's okay.
Doesn't your laptop just do that?
Mine's not cool though.
What? Oh, it's not, you mean it's not green? It's not like a.
Well, that's what I meant.
Okay. You just need like a razor font?
When I was investigating keyboards to perform with, I found there's like a whole array of crazy illuminated keyboards. Almost none of them are battery powered because once you're doing the light shit, like you're not, Yeah, a lot, like more than
So basically all you're going to have to do, maybe swivel this around a little bit if you want, basically just that top little bit.
Point.
That's all you need. Yeah, point up at my face. And then I can even almost leave it in the scene we need, but basically there's a couple different scenes. So this is what's live right now. If you hover over, you get a preview. So one is title card.
Where are these inputs coming from?
It's all set up.
Oh, okay,
Yeah.
that's cool.
So one is title card, two is live cam, three is live capture, whatever's live.
Okay, so 3 is the presentation.
Yeah, well, but then there's 4 is capture plus webcam, and 5
Holy
is
shit. This is next level. Okay, well, I
basically
can't,
all
I
it'll
can't
be-
promise amazing
yeah,
production.
all I need is switch to scene 4.
Okay.
Because we'll probably, I'm on the card, probably
Rotate this and switch to scene.
rotate, make sure I'm in frame, switch to scene 4.
And I click on the scene to force
Just click on it and it'll cross it over.
I got you.
Once we're done, click back.
I will do my best.
Yeah, it's easy enough. Mostly it's just making sure that I'm framed.
Right. I can do that.
It's a funky camera, but it's amazing how hard it is. I was looking at solutions for like good cameras with USB streaming. Like
They're almost, well, this is what the Elgato is great for. So I have an Elgato Game Capture HD, and they have a 60 FPS one now, and it basically turns any camera into that.
Yeah.
And it does the H.264 encoding on the hardware, so that's how it gets through the USB, is that it's coming in compressed.
I wonder if I could do two, because I'm doing, this is basically the same thing. It's another media
yeah, so it's
capture.
basically
So that's how I'm
exactly-
getting this. I was a little dubious of running 2 at once, but maybe it would work.
Well, if you've got USB 3 and they support USB 3, then yes. With USB 2, you're going to be pushing the edge of the bus, but it depends. But like the Elgato has a quality thing, and if you dial the quality all the way down, it's sending like almost nothing through the USB line. It's just compressing the hell out of it before it even goes to the compressor.
Which is basically what this is, right?
They're basically the same thing. So in theory, with USB 3, it will work. With USB 2, it might not.
It's worth a shot.
But the Elgato, for me, has been one of the most valuable tools it's had around, because there's been 1,000,001 situations where it's just like, we need this right now. It's like, oh, the Elgato will solve that. And I don't even have the new 60 frame per second one. I just have the old school USB 2 one. So.
Let's turn on the air. It's getting pretty warm in here.
Even though it's winter.
Apple really like, it's not the case that they're like, whatever, just change it here. So I was going.
Do you know this guy? He's the incompleteness theorem guy. He's got Buchwald on his name. Do you know how to pronounce that? Goodell. It's not Goodell.
Goodell?
Is it?
I don't know, man. I would ask Google to pronounce Goodell.
How do you pronounce something with the
So, umlaut for you.
Vernal? Little?
Just Google pronounce Goodle.
Oh, here we go.
There you go, yeah. Cool. Goodle.
Thank you. The slide in.
Tweet it out. Streaming.
Oh, nice.
Three people watching.
3 people. Who are these people? Is this the mic?
This is actually.
That's the mic. Okay. We're going to be starting in about 4-ish minutes. 4-minute warning. So how's yeah, I was gonna say most of my friends and family are going through that right now. It's like they look like they have flags now, the 7 layers. How was that like? Yeah. Yeah. Well, that's what people keep always tell me is that, like, as soon as you get used to something, like, it just changes drastically. It's like that's a better thing than, what do I know?
I mean, like, I tell my friends I have a baby. They're not all like. One of my friends had a college baby, like,
Yeah. My brother and sister-in-law are on their second now, and it's just totally different. Like, the first baby was just,
yeah, it's a nightmare. I mean, this yesterday was just one thing. So what they probably did is make it easier for them, just not do all of the crazy purple shit. They probably started off with most systems and delivery after. Seriously. Yeah, I take my family out. It's the best food. They just like like stressed out. I'm glad it's yeah. Well, it's hard because it's like I try to like do that.
That's keyboard lights. Neat. I thought we were using this.
Oh yeah, for sure. Yeah, something like for sure.
Oh, I was going to do a little bit like kind of housekeeping. There's like informational stuff. All right. Hello. Hello. We're going to go ahead and get started. Real quick, if you want to be on Wi-Fi, that's the Wi-Fi stuff there. There's going to be some sort of like general housekeeping slides, and then we'll get started with Bill's presentation. So welcome to this event. So for some introductions, hopefully people kind of know people by now. I see a lot of familiar faces. But my name is Ben Purdy. I'm going to be kind of wrangling the schedule, I guess, tonight. This is Surya Buchwald. He's what is your title at Helios? Like director?
Director of Innovation.
Awesome. That's amazing. So he works here at Helios. He's doing kind of like, I guess, technical and host kind of things tonight. We've got Josh Michaels over there who is helping with all this kind of general organization. And then I'll introduce the speakers. That's the Wi-Fi. Food and drinks are back there. It looks like most people figured that out. Bathrooms are kind of like back past the kitchen. So there's some upcoming things we're going to touch on real quick here as well. A couple of events. There is a gallery show that Josh is putting together. Would you say you're putting it together?
Yeah, and actually, let me ask a question real quick. So I'm doing my first solo gallery show in January at Up4. This is a pretty big deal for me because I actually did the math today. I've done 27 art shows so far and featured 1,124 artists. 1,052 of those artists were never actually at the shows, but they still had their work shown. But the point is, I'm actually trying to put on a show of my own work for the first time. And I am in need of VHS VCRs. Is anybody here, I know it's strange, you'll get it in January, more one for you. But if anybody here has a VHS VCR that they do not need, especially if it's one of those very special ones that can copy VHS tapes, I am more than happy to take it off your hands at a reasonable price, or you can donate it if you so choose. But if anybody here has a VHS VCR to spare, please come see me. I'm more than happy to take it off your hands. But otherwise, you'll get an invite to the show. The opening is on January 7th. It should be fun, and it involves a bunch of VCRs. So.
Awesome. So the other thing that's upcoming, the dates are still a little bit up in the air, but there is sort of like a global digital art event that's been happening for a few years now, there's some folks here in town that are trying to get Portland onto the list of cities that are participating. So around the last week of January or so, that's going to be kind of starting out, and I think it's like a one weekend event where like all of this stuff goes on at once. So you can find more information at this URL here. The next meetup for this group is going to be on January 20th. It's going to be at Second Story next time. You can always find the information on the meetup URL. Also thank you to Helios. They are providing the space that we're in, which is awesome, and the snacks and drinks, and putting up with us coming in and making a mess of the place. And also, Surya wanted me to mention that they are always looking for people, and especially coming up in like Q1, Q2 next year, they may be reaching out. So if you want to get in touch and inquire about that sort of thing, email Surya. He's really nice. He's sitting right here.
Surya, what does Helios do?
Helios is an experience design studio. So what that means is we build interactive apps and games, mostly for live events. So we do a lot of sporting events, we do conferences, trade shows, museums here and there. So we're mostly like a digital partner. So we build the software that people get to play with at the events.
All right. So one thing that usually we'll try to do at these sorts of events is get people to meet each other. So before we get started, this is the part where we all awkwardly turn to our neighbors and introduce ourselves. You can stand up, that makes it less weird. Just say hello, break the ice. It's great. Okay, stop being rude. That was great. You can sit down now. All right. That doesn't usually work so well. Okay, so I'm going to go through really quickly the schedule for the evening. So we're going to start at 7, which is 5 minutes ago. We're going to start with some presentations. We've got a short interactive demo after that Surya's going to be presenting. And then after that, at around 7:50 or so, or just whenever things wrap up with the presentations, there'll be time for all of us to just kind of mingle around, and hopefully you brought something to share or just kind of like describe or demonstrate, and it'll just be kind of like happy hour style mingling. And then at 9 o'clock, we all have to leave. So, now we need Bill. who is standing back there, not paying attention. Bill! All right, so this is Bill. He's going to be telling us about how to use unit testing. Would you call it unit testing?
Yes, exactly.
Various dev testing to make your art projects better.
Yes.
Yes, that's what he's going to be doing.
Cool. All right, let's go to my slides.
Awesome. You can find them on this
Fantastic. Let me put my notes up. Awesome. Great. This looks great. Okay, cool. Hello, my name's Bill. I'm going to talk about how to be faster and better at what you care about, which is ideally art. And how you do that is through the really boring, dry software engineering task of tests, which is something that nobody wants to do. And it's kind of a mystery, and I hope that this talk sheds some light on it. I'm going to use like sweeping terms like you should and you can't, and I don't want to be like that this is the only way to do it. It's just one way to do it. So, all right, great. So let's get started. Part one actually is a quick history lesson on kind of where we started with all this, and it starts around the turn of the century, the 19th century, or whatever, the 18th century. About 1920, math was running into all these paradoxes. We were getting so good at it that we were finding all this stuff that blew our shit up. And we have this crisis of identity, not so much like how do we do math, but like how do we come up with new math? What are our methods to do that? So what is math? This is all valid. You can just kind of feel your way through math. It's fantastic. Or you can come up with a bunch of formal rules and just memorize them and use them, and that'll get you all the way to the moon. Or you can do what we do these days in America, which is logic. Or we can do what physicists concern themselves with, which is realism. Things that, like, if it's not something that I can touch or throw at someone, it straight does not matter. To my world, I'm a farmer. I make potatoes, you know. And I have math that I need to do. So the reason why we use logic is because it's well documented and it's taught in our schools. That's absolutely the only reason. And it is well organized, and I'll tell you the story of it. Like formal logic, like capital L. And okay, cool. So what is the purpose of math? It is a philosophy that you can use to get answers to your questions, especially mathematical ones. But what happens when you have this really sick philosophy and you apply it and you get a paradox? Usually, your philosophy is supposed to be like a way to get around a paradox, or even isolate it into, compartmentalize it in neat little groups. But sometimes it doesn't work like that. This maze that it helps you navigate is actually hindering you. So we got organized about it. So what's a paradox? This slide doesn't make any sense until I tell you what it is. So what's a paradox? So a specific example of a paradox at the time was it's called a Russell set. And what it is it tries to describe a set of everything. So what's a set? A set could be what you would call an array or a collection or a list. It's just a bunch of stuff. So it's like all the numbers between 1 and 2 inclusive, or all cats, or everything that's not my family, or a set of everything. So this is a set of everything. It's every single thing in the universe that ever was or ever will be. It doesn't matter. We can construct this by doing the contra something to the set of nothing. You know what I mean? Like in your equation, if you had one side of your equation with a set of nothing and you need to like divide by all these things, you would find yourself needing a set of everything. And the paradox here is that a set of everything should also have a set of everything inside of it, which things start breaking down because now instead of your equation having things in it, it has an infinity in it on one side. And that's like a paradox. It's like a bug in your philosophy of how to approach your problems regarding sets, which are actually very important. Here, so let me scroll down. So math kind of shifts away from being like a way to navigate paradoxes to a way to isolate them and organize them, and being able to identify things that you shouldn't concern yourself with because they don't make any sense. Like in math, if you ever hit an answer that does not exist, that's math going, go away. or undefined is an answer, or an answer that's both negative and positive infinity, stuff like that. And you use that, and it's kind of an answer, but it's also like kind of a cop-out because you have to stop there. So these people decided that they were going to do something about it. This guy in the middle, especially. These guys are crazy old. Look how seriously, like, this guy is not. And he's actually Bertrand Russell. He's the guy from the Russell set. He's done a lot of other things besides math too, but this guy in the middle was like, there's 18 things broken with math. And they wrote them all down, seriously, it's these huge problems, and these guys set out to fix at least some of them, and they did in this book and a couple others, but mostly this book. It's 260-something pages, where they come up with something that should look really familiar to you. Variables. I mean, we had them before, but we really didn't. Have them like written down in a way that was, you know, formal and like in a book that had a Latin name at the top. If-then statements, true and false as values, not so much as like ideas, but like what is true times true or whatever, it's true. And then like the idea of organizing things in parentheses and symbol strings, like when you were in calculus class and you had x sub s, that's these guys' fault. So like they did all the work. Look at their work. This is page, no, seriously, this is page 180 something, 182, where they do all this work to prove that 1 + 1 = 2. And really what they're doing is that they're defining what 1 is and what it means to plus something, what it means to equal something. And they do all of this so that they can reuse it in 3 other places, in some other proofs that are even denser than this. That, yeah, I was going to have another slide after this, but I gave up. Like the use of 1 + 1 = 2 is really advanced. Anyway, so, okay, so they did all this work and they were successful for the most part, really, until this guy came along, Gödel. He said, he proved that any system is going to have paradoxes at its bedrock. Like, any system is going to have to be self-referential because it's a system. It's going to be incomplete, like because there isn't something that exists outside of the system to explain it. It has to be self-referential at some point at the bottom. So I included this part. You know, I'd say that they solved it, but really they didn't. Know that like there is an end to how hard you have to work at verifying your programs. At some point, it's impossible to work any harder. So like this seems like it sucks, but just know that it ends. Okay, cool, great. Part 2 applied. So this is a talk about side effects. So like when you write computer programs, they do billions of things a second. And when they do things wrong, they do things wrong a billion times a second, right? And it fans out in this way, and like supporting systems break in ways that you can't expect. And if you have encountered a bug with your program and identified what was wrong and will write every single time, congratulations, you're the only single person that's ever happened to. So like when I talked at the beginning of my slide, or the first slide, faster, better are through tests, I'm trying to minimize this time. So there's time that you spend writing code, typing, and then there's time that you spend thinking about your code, like while you're eating or whatever, going on a walk. And then there's time that you spend angry at your code because you have no idea what's broken, and you're just repeating the same steps over and over again, screaming at this black box. So this talk is about minimizing that time. Or, yeah, okay, cool. So, who identifies with Homer? Right? Seriously, this is, what happened to Homer here? Of course, his code works. This is the function he's writing now. These are the functions he just wrote. Cornflakes works, milk works, it's not on fire yet. What happened? Well, no, what happened was he didn't look in the milk container to make sure that it didn't contain white phosphorus, you know, because, no, seriously, the milk people make all white phosphorus. There's a mix-up at the plant. Or these cornflakes are 100 years old and degenerated into something else, so they're not cornflakes, you know? But seriously, like, he didn't verify his pieces before he plugged them together, and now that they're on fire, he can't, like, work his way backwards? So what Homer needs to do, I love this. You know, repeats videos. If you go in the thing long enough, it'll show you. So, all right, let's get off this slide. Okay, so really goes right to that from Homer? Yeah, it does, doesn't it? Okay, so how do you test something? Or what does a test look like? We'll go right to it. This code's kind of hard to read. It doesn't matter. We just need to see what the shape of it is. On this first line, we set up a variable. In this test, what we're doing is we're testing the split function in JavaScript for strings. You have a string, 1, 2, 3, 4, and you split it on 2, and you'll get 1 and 3 and 4 as the result. So I split a string, oh my god, LOL, and I split it on the G character. And then what I'm testing here is, this seems really simple and it's basic, but it's immensely valuable because it's actually verifying that split works. And you don't think you need to test split, but the person who wrote split tests split in a bunch of different ways with a bunch of different input beyond just one string split it on a regular character. So here's the test. It's really simple. Is the result of the test ZOM for the first element of the array? Is the second LOL? And the test passed. That's awesome. This is a really basic test that it's just code that runs. You run more than one test at a time. So here's a test block. The test, you don't need to read this. It doesn't matter. You know the shape of the code. So this is a block. It's a function that just runs. The very first line has the name of the test. The second line tells the test runner that there's going to be 4 tests. I know that seems nitpicky, but it's important because sometimes tests can fail so hard that the test runner doesn't complete, and it like hangs, and it, your tests automatically don't run. Anyway, so it breaks down, and if it knows that if it times out, if it didn't get through 4 tests, it knows one of them failed. So, all right, so the second block is, all right, sorry again. What this test is testing is a normalized function in a vector, which takes a vector of any length and makes the length of 1, right? So it initializes a vector, and then it tests it 4 times in different scenarios. So like math is very hard, and it can break down in certain different ways. And different ways that it can break is that if you have 2D math, you should test it in different quadrants. You should test that your vector length is 0 at 0, 0. You should try to test it a flat vector's length and stuff, because the way that you were doing it, especially if you go back and change it, there could be weird exceptions, especially in math and computers, where a paradox is the fact that floating point numbers don't actually happen the way that things work. The 0.2 plus 0.1 is not 0.3. That's a paradox, just in the same way that you can't have a set of everything. Like our system of how we do math, the philosophy of computer science, has paradoxes and bugs in it. You cannot have a 32-bit number bigger than 2 billion and something, Okay, so we just tested the split function by feeding it. You give it an input, and then you have some expected outcomes that and you're going to have a list of them. So that was testing function returns. Other things that you can test for, so you run your program, or you run your test suite, and if I made a vector, like how I did here, I just made var v equals vector, I can test to see if there's an x component to my vector, just by checking to see if it's undefined. So you can check variable initialization. If you create an empty vector with no initial numbers, should those numbers be 0 or something that you set because of your program design? Check for missing assets that load. Check, you should have something that checks your arrays for things that are not numbers. Especially very large arrays, seg faults happen all the time when numbers are multiplied by things that are not numbers. Other things that you can test are events firing by you create, like in a browser, you would create like a fake mouse event and fire it at an element that would normally be clicked manually, but your test doesn't happen manually, it has to happen automatically. All right. Some other kind of stuff that's more kind of bookkeeping in business is like if you're making a buffer, usually it's not 0 length. Database writes are always really simple things to test for. You write to the database and then you look for that thing that you wrote for. Was the request, search for these elements that match this ID. Is the length 1? Then my test passes. All right. So those are all tests for things that you plan for, that you expect to happen. Testing is fantastic because it describes your program. When I don't know what a program does, I can go read the tests because it should say that vectors normalize. Vectors can add. And I can read all the special cases of the tests where if I initialize a vector with nothing, it should initialize with valid information. But every single bug that you get should get a test. I had a particle system where the particle goes off all the way to the edge of the screen, and instead of wrapping to the left, actually I was having it acting on the Y component because I copied and pasted. So when I got a bug for that, I checked to see that if a particle greater than the width, does the X component get updated as opposed to the Y component? And it seems really simple, but how many times have you fixed a bug only to have it come back? Well, if you created a test for it, while you're running your tests, if you change another element of your program that would have caused that bug to reappear, a regression, the test would find that out. You wouldn't have to go and run that portion of your program in order to make that happen. Okay, cool. So here's another example of actual bug-related tests. I wanted this talk to be somewhat applied, but code light, because I have a repo that's a particle system that is completely tested and has very well-described tests that run very quickly. Here's an example of a bug that you should test for. If you make an HTTP request, the status, you should check to see if it's 200. But I've got a bunch of requests that were empty. There were 200. That came back with nothing. I can't draw an image that's nothing. Or what if I only get 32 bytes or 8 bytes? The image width is going to be, it needs to be greater than 0 at least. I can't tell you how many times something that you don't expect crops up and tests like this save. So let me make sure that this next one. Okay, cool. So this is a good example of the type of test conditions to differentiate between, really quickly between something called an integration test and a runtime test. So certain types of tests can happen independently, like if you had an asset loader that just loaded all the assets. But other types of tests need to load like literally when the program runs, like if you have it loading in where it's going to live. You need to test like it there, especially every time it runs, because things can fail silently, especially if tests passed earlier. So this is an example of a test that needs to run. The purpose of tests are to isolate your code, but this one is definitely one of these that needs to be, completely integrated runtime. Okay, so the repo that I have set up is just a basic particle system that exists in a world and has multiple emitters that have multiple particles that contain vectors. So I'm just going to go through really quick. So when you test a vector, you test the constructor, and you check to see if there are x and y values. Immediately after that, because you know that those work, you check to see if the set function works for those two values. And since you have an actual set function, you can start operating on these values. I hope that, So with the add and multiply, these are really simple. You would make a test where you just add a vector with a length of 1. These are interesting like helper functions where they would identify that you're adding a vector instead of just simple components, and then they call these functions. So you would verify that this function runs this function. But since this function is being tested, it's even more self-supported. And then once you have these parts, you can take it into more advanced, actual useful like algebra mathematics type stuff. So since you tested your vectors, you can use them. Since you verified that you can add them together to get the velocity to be added to the position, you can now incorporate them into a particle that can be tested. So this should be kind of repetitive, but it should be like kind of consoling in that sense. You're going to test that particles get created and all these variables are made. This one's interesting because the particle would create an element on the page. So you can actually create a particle. It should be added to the web page, and then you can like query it with jQuery or just the regular JavaScript, and like count to see if there's one element being added to the page. An emitter in its constructor tests would check to see if there were more than one or more than 0 particles in the particles array, and that there would be more than one force function in the emitter. I'm going to show you how this works in a second. So how the emitter works, I'll just tell you, is that it contains a bunch of particles and a bunch of functions that act on those particles, and there's just like an array of functions. So every time it ticks, it goes, for every force function, act on every particle, and then, tick those particles. Cool. And then finally, there's a world function that has like less tests. You should have seen that there was, considerably more tests at the bottom than there was at the top of this, because this is kind of more in flux than vector math. You know what I mean? Like once you write tests for that type of stuff, you're done. But you're constantly rewriting the test to describe the functions for this, for like the very tip of your program where you're constantly coding. So this, the final object, is the world constructor that creates an array of emitters that are verified, arrays of particles that are verified, arrays of vectors. And just like the particle, it's checking the page to see if an SVG element was created. So multiple layers of your tests can talk to multiple layers of your program. This should give you the impression that tests are going to force your code to be more modular and actually enforce that, as opposed to it just kind of being like a nice idea that you have, that your code would be all right, cool. So yeah, we'll just leave it on this because it's entertaining. All right, so that last part was kind of quick, but there's I just wanted to show you that every single thing, even very mundane things, need to be tested. The cornflakes need to be tested. The milk needs to be tested. Not this immensely good combination. This is the world. These are the emitters. Those are the particles. You need to verify independently, or things will blow up. Let me do the last of my notes. Cool. Yeah, this is a lot of information. I wanted to impress that it's feasible to take your art ideas and break them down into what you expect to happen, and then actually verify that those components work in a way that integrates with your workflow and makes you happy. I swear to God, if you write passing tests, when they fail, you will be like, oh my gosh, this is the most amazing thing. I have a bug that I can fix that I know what I need to fix. It's not just this black screen. Cool. All right. So further reading, if you want to Google this, Google unit testing and test runners for your language. There are unit tests and test runners for every single language. And the link to my repo is bit.ly.com, remember Homer. I want you, when you're at home, working on your programs, when they are broken and you have no idea why they are broken, I want you to remember Homer. And then later that night, go and just read the test directory on this repo. Yeah, it should help. OK, any questions? Yes?
Is there a critical point at which your art is so sophisticated that you really should be writing tests for it, as opposed to kind of when you're tinkering around and you're not sure about it, you don't write them?
If you won't be there when it runs, there really should be tests. If someone's paying for it, there really should be tests. Yeah, if where I was introduced to tests was in my professional work, I need to work on a team. Oh yeah, especially if you're working on a team. Tests are fantastic because someone can submit a patch or a change to your code, and if there's a supporting test, it's describing your change and all the conditions of where, what it's doing. You can read, as opposed to actually running it, where you don't know what it's doing because it's doing a billion things a second. Yeah, people are constantly writing tests, writing C out and adding things and typing debugger and semicolon and clicking around is a fantastic way to test. But writing unit tests is a much better way to test. Yeah. Any other questions? Yes.
Do you ever do test-driven development, and do you want to mention what that is?
Sure. So test-driven development, correct me if I'm wrong, is where you start with the tests. Yeah, so you design a spec that a vector is supposed to have an add function, and you write a failing test. And then you write code that satisfies the criteria of the test. So you would start with something that didn't even initialize, and then you write an initializing function that makes the variables not nan or undefined. And then, yeah, so cool deal. Yeah, and that's like, that's a philosophy of coding that I don't do. I would say that I write a little bit of code first and then I test it, because you have to have something that's actually going to like load up in your program as opposed to just kind of like it immediately crash. Usually tests don't crash your program, they just fail. Like you expect 1 and you get 0, or you expect 1 and you get undefined. Any other questions? Yes.
Have you ever had trouble figuring out that the bug was in your test harness or the test itself?
Well, there's like the idea of, so the question is like, can your tests be the source of the bug? Or like, can your tests be hiding a bug, I guess? Or can they contain a bug? Yeah, I haven't run into that yet, but I'm really racking my brain, but I haven't. But, you know, it's more than possible, like in the sense of, you know, your program can be so, you know, so complicated that it's, you know, or you're trying to write tests for something that already exists. And, you know, once again, your idea of it is, you know, it's like this black box and you're just kind of scratching at it. So, there was one more?
What do you do with the results of your tests?
Okay, cool. Yeah, here. So, I had a, here, let me go. So this is the really cool repo that I wish that I was showing, but here's tests being run. For this repo, there are, oh, one there's failing. Why? Oh, that's funny. Okay, cool, that's great. I'm glad that one of the tests failed. So here, let me zoom out. So automatic tests that like can run, like if you don't need a browser to run this test, like you can do vector math just using a JavaScript runtime. So you can run your tests, like there are test runners called Travis. They're called continuous integration test runners, and those can like be saved like for later use, and every time you make a commit, you can have your tests run. And you can like go chart back and like see, or like this, you can have it, I have it dump to the console, or another good way is to have, you know, the very, like when your computer boots up, I know, you know, PCs do, they test the memory, and it just displays, and it can just, your test can be the very first thing your program does, and then your program can run. And that's a fantastic way of doing it. You don't have to like run your program and go clicking around like some jerk. You can just scroll all the way to the bottom. So what I did here was, here's this test that's failing, and that's fantastic. It's the very end. This is an emitter test, and it's checking to see if the particle array is populated, and it found 64 particles when the test describes 100. So, and that's because I went and changed it to 64 because I added a third particle system to this setup. So, and really quickly, what I'll describe that this is doing is, I'm always building like little lab environments for my code because I'm convinced that like really tiny changes are very, very important, and I want to run code side by side. So this is running effectively the same particle systems with tiny or different settings on top of each other. I feel like you can't really know what's going on with particle systems if you run it, close it, run it, close it. I can't remember. Garbage collection. Yeah, so this is, so there's a world, and there's 3 emitters, and each emitter has particles, and each particle is floating around, and each emitter has a different set of force functions applied to it, and that's found in main.js in this code. So, yeah, and you'll find the failing test committed to GitHub. So, yeah, that's great. That's actually really educational. I wanted to have a failing test. And that's a failing test that's by design as opposed to like there being a bug in how my program is constructed.
Just to give some guidelines, how much time do you spend writing tests as opposed to writing code?
That's an interesting question because I feel like I spend the smallest amount of time writing code of anything. And that like people who talk about like the verbosity of code and like the literal number of characters that you're typing, I feel are not seeing the forest for the trees, and that you spend, so I spend way more time writing tests than I do, writing the code, and I would say that I spend way, way more time thinking about the code than I do writing tests. So, yeah, like writing documentation and what I think the code should be doing is where I start, and then I write the code with tests. Great. Yeah, no more questions. Fantastic.
That was awesome. All right. So our next presentation, thank you very much, Bill.
Yes,
That was great. I have a personal story where that could have saved my butt, but I won't go into it. Just things get crazy in like non-memory managed situations too, where like your debug environment and your like dev builds might behave very, very differently, and testing can save your butt there. So the next presentation is going to be Surya. He's going to be showing a project called Happy Trails, which I guess I'll let you describe it, but I understand it to be sort of like an interactive performance tool or toy or experiment.
Yeah.
All three combined, something like that. So I don't know which machine you're using or what. But
I'll be using this one. So
okay.
switch over there, yeah.
So there we go.
All right, so would you turn down the volume there for me for a moment? I want it back up a second. It's the big knob. Yeah. So hello, everybody. I'm Surya Buchwald, also known as Mo the Monster on Twitter and elsewhere. So this is a system that I've been working on that I'm just going to give you a short demonstration of. First a recorded one, and then we'll do some live jamming. So this is, it is currently called Happy Trails. I think that's the title I'm going to stick with. And it's pretty basic. Stay right here. It's drawing lines on a screen at a very basic level. And I've been I started from that, I like drawing lines. What can you do with that? You can affect, the width of the line, the amount of time that line is on the screen, the texture that that line draws on the screen, etc. So that actually started, I taught a Getting Started with Creative Coding in Unity workshop here this last August. And that's the sort of simple to get started with thing that I came up with for that workshop, and I've continued to iterate on it. So actually the very basics of this are available on GitHub as workshop trails in the Momo the Monster GitHub. But this version has some things that have not made its way to GitHub. They will all eventually. So I'll start with a quick demo. This is a YouTube video. You can see a little capture. You can kind of see down here just the actual live input. Funny little note about how I recorded that, because I was trying to figure out the best way to both show the output, because the output is most interesting, right? You want to see what's on the screen, you want that nice and high res, but it's also, I think, way more interesting to know that that's being generated live and it's not just random. I think that adds a lot of context. I think I've got another video playing. So what I actually wound up doing for that was I used a touch screen that was in front of me down here at my desk. And then I just took this kind of camera and hung it off of my collar, just looking straight down at my hands. So it's a really hard shot to get, actually, of like yourself using a touchscreen. But that actually worked pretty well. So like if I move around a little bit, like it follows around with me, and lo-fi solution there. So this is a version. So originally I was just going to show Happy Trails and do a quick demo, but Philippe kind of issued a challenge in the Slack channel with some snowflake inspiration and said like, hey, let's maybe do something with snowflakes for this next Creative Code meetup. And I'm like, challenge accepted. So, but with limited time and everything, basically what I did was I took Happy Trails and like kind of just made a preset for it, where like honed like exactly which textures I'm using, and I changed the shader that does the mirroring. So if you guys have seen my work before, I love mirroring. I think it makes everything look great. So the most Happy Trails is usually used with a symmetrical mirror. You can turn that off, but it looks better if you leave it on. So what I instead did was I did a kaleidoscope mirror. So a 6-up mirror. Yeah, it does 6 reflections based around the center, and that was cool. I might as well show this instead of just talking about it. So here, I'm just running in Unity for a variety of reasons. It lets me show you what I'm doing a little better. So we have the basic movement here, and then any movements I make are going to be reflected. One interesting thing that I had to do, and I find that I have to do this for pretty much any time I implement mirroring in an application, is usually when people write mirroring shaders, they do it such that you just take the left side, let's say, and you copy it to the right side. But that means that if that's your canvas, you only get to use the left side of your canvas, and that's kind of boring. So what I have built into Happy Trails, not this version because the shader is new and I'm working on it, but you can switch. It'll take the left side and take it to the right side. It'll also take the right side and blend it with the left side. So basically you sample each part, and then you can do a variety of operations. Simple things like if you add those colors together, you're doing an additive operation. You multiply them, you're doing multiplicative. It's a hard thing to say. And then so I had some fun playing around with like min and max, and what does that look like if you do a max? It turns out I really like max for most of these. You wind up with like nice saturated colors without ever blowing out like add or screen modes can do. So in the Snowflake version of Happy Trails, I think we're mostly stuck in a max because I don't have the key codes for input. And yeah, every time you put your finger down on the screen, you'll see that it's modifying those 3 variables, color, width, and time. So I have ranges that are considered good ranges for these 3 things. And this way it's always a little different, but if I click on width, it takes the little shuffle off of width. So now I can make, the biggest one that I allow, and it'll always be big, or I can make it really, really small. So we get these little tiny tech lines. Some fun stuff there. I also threw on for the snowflakes, or a Figment as well. I have some particles, some little boxes that come out, because I also love boxes. Yeah, so that's basically where Figment is. I can turn off the time and always have, let's see, short but thicker ones. Let's go really short. This way it's almost like waving little flags in the air. And then you can also see down at the bottom of the screen what brush I'm actually painting with, which is interesting. So like this one is kind of a cool brush because 2 lines side by side turn into a trail actually winds up looking like 2 trails following each other around because of the way that they're applied. So that's cool. The circle winds up being like an outline. We have this, I found this one by accident. So this is kind of a bunch of squished gobbledygook text that doesn't say anything. And I found that because, kind of because of the way Unity works. So like you can have a material and then it's really easy to take a material and just cycle through any texture in your project. So I was cycling through textures just to like see what looks cool. And I wound up accidentally, there's like a logo for this tweening library called DoTween. And I loaded their logo in there because it's in my like total list of textures. And I was like, dude, that looks awesome. So then I played with letters that looked kind of like that, but don't actually say anything. So I wound up with a bunch of these things. Yeah, I think it looks kind of neat. So I'm going to, all right, and the reason I left it in the editor is so I could switch colors around a little bit. Ideally, this is totally, loading from presets or a file or something, but for right now, I do this really silly thing of just moving around the order of things. So now Snowy's on top, so now when I make snowflakes, they'll have this color palette instead, which is a little more snowy. I'll turn that music back up a little bit. So that's roughly where Happy Trails Snowflakes is. I do have it running on a touchscreen back there, so feel free to play around with it once we kind of break for social time. And all right, so one part I didn't mention, and this is the reason that I have to do this funky moving colors thing around, is actually this is totally network enabled. I don't have a demo of that running, although if that machine was online, we'd actually see it on both. So I've been trying to learn like multiplayer gaming and multiplayer application stuff. So this was like a kind of an easy test. So all right, I have the thing off, but usually when you start it up, it would tell you if you're connected, you can host a game, you can join in clients, and everything that other people do shows up on yours. And the reason the ordering of the color palettes matters is that the top color palette is what shows up on your screen, and the bottom color palette is how everybody else's work shows up. So you can see what other people are doing, and you can kind of jam together, but you can also tell really like what's yours and what's someone else's contribution. So yeah, that's a fun thing. Any questions about Happy Trails and Snowflakes? Yeah.
What kind of stuff are you using for networking? Are you using like any Unity packages or?
Yeah, so a question was what I'm using for networking for this. So in Unity 5.2, they introduced their own, or they upgraded their own networking layer. So it's totally built ground up in that. I've like played around with some of the other network packages, and there are great packages out there, but now that Unity is like really putting some time into their own networking, I thought, all right, we learned that one, that'll probably be supported the longest. Because some of these other network packages I bought into, you know, they go away after a couple of years because it's a lot of work to keep up, you know, an asset for other people.
That's cool. I didn't know they even did that. I've done a little research around 5.1 and saw that they're pretty much everybody's using like third-party libs to get what they want.
Yeah, there's a number of libraries that have been very popular because Unity either didn't really have support or had not a whole lot of support. But yeah, their new version, you know, it's still kind of a new product and there's still some things they're figuring out, but they have, they're pushing it because they run their own like matchmaking servers. So if you want to do internet enabled gaming, you know, they have servers you can play those on, and matchmaking, they'll do finding the closest servers for all your players so that they have the lowest latency, important stuff like that. You know, mostly what I'm doing is probably for local networks, so which is an easier kind of multiplayer to do because you have so much less to figure out. But yeah, so far it's been really strong. They take care of a lot of network sync things for you. There's still a lot of other issues in making something really feel right across the network that now I'm delving into. But thankfully, there's also a lot of really great documentation. Valve in particular, it turns out, has published like basically the Bible on multiplayer syncing and networking and making it feel right. So I've been pouring through those documents, and that's been a cool journey. Anybody else? Excellent. Well, thank you very much, and make sure to try out the touchscreen on your way out. It's back to you.
I don't think there's really anything else on here except for people to stand up and chat. All right. Well, this is the part where we've got about an hour or so to just kind of hang out, and if you brought stuff to share stuff, talk to people, say hello, and that's all of the things. Did anybody else make snowflakes? No other snowflakes.
I'd like to make an announcement before you break. If
Sure, yeah.
Okay, thank you.
It's been a while.
I'm Carlos.
Yeah.
How you doing?
Great. This is Carlos.
Hi, I work with Afro Gallery. We're a local gallery. I don't know if you've heard about us, but we have an event each year called Bite Me, which is a technological art exhibit. The reason I'm here is to let you know about it. We're accepting submissions. You're all creative coders. I know a lot of you also may do some art on the side that has technology. Libby is has a longtime Bite Me artist. I just want to let you know about the show. I have my email address I can give you if you have something that incorporates technology and art. We're looking for that. The show is in February. Your piece does not have to be complete to get in the mix. If you can commit to getting it done by February, I understand it doesn't have to be perfect. There's little things that might not be done, but if you think it's good enough to show, it's a really good turnout. This is the 5th year that we're doing Bite Me. Each year it just keeps growing. We've had a lot of amazing Portland artists and regional artists join, and we've really been exposed to some amazing pieces. Yes?
When does your call for artists kind of close?
It closes, I would say, it's going to actually close the month before. So we're accepting submissions through January. What we would like to know is if you have something, we want to put a placeholder for you. So let us know. I'll send you the details when you email me, but what's the name of the piece? What requirements do you have? Power, dimensions? Do you need lighting or dark? Do you need music? There's some questions that we're going to ask you. Is it for sale? Is it not for sale? Just stuff like that. But if you just have something that's in the works that you think will be done by February and you can commit to that, we'll take it. We have some openings left, and we have a lot of space, so we can make it work. But we really want to just get that commitment. Like, yeah, I've got this thing. I needed a deadline, and I'm going to make it happen. Sean Hathaway is here. He's a co-curator with me for Bite Me. We've been doing it for 5 years. Very successful. There's stuff online. I don't want to jabber on too much about it, but it's an excellent show. It's one of the few opportunities for creative coders who are also doing artistic side projects to get that stuff out there. It could be robotics. It could be screen. Interactive theme is really one of our fortes. We like things that the audience can interact with. There's a few hundred people that are going to walk through. It's going to run all month of February, and it could be big. You can be like, I need a 14 by 10 projection, and I need all this stuff. We usually will make it work. So Sean and I just came here tonight to tell you about it. We still have lots of slots open, and if you raise your hand, I'll give you my email address, and you can just email me back, say I'm interested, send me more details, and we'll do that. I don't want to take up too much of your time, and I appreciate letting me get up here and let everyone know about it.
Yeah, thanks a lot.
Sorry, yeah. If you're, raise your.
We can also just send out information to like the Meetup mailing
Just
list.
do it to the whole thing? Okay. But if you want a card right now, raise your hand, I'll give it to you.
The chairs, putting the chairs against the wall, and we'll bring in a table to set up.
Oh yeah, okay. So I have just been informed that when you stand up from your chair, if you could fold your chair and kind of move it off to the side, we're going to bring in tables. So if people want to like set up laptops and stuff like that, we'll have space for that. So yes.
Hey, hi, how's it going? I'm Ayla. I'm not a developer, I'm a producer. I work for an agency called North here in town, and we have a brand that is giving out money to filmmakers to do a film that's an expression of the brand. We want to get them to also do what's the digital creative expression of the brand. And I can't tell you too much about the brand or else I'd have to kill you, but basically we're looking for art and code in a beautiful way that's an expression of the brand's sort of mantra. So I also have cards, and this would be like if anyone's looking for freelance gigs or know anyone who is, then come find me and I'll give you my card. Okay, thank you.
All right.
All right, let's move those chairs.